Okay, today we're going to have a look at the exoplanet features, at least the most important ones to do with NextAstronomy. So NextAstronomy, you either put your telescope on there, you have permission to use someone's telescope that they've put on there, or you are a user and you've signed up for a membership to get Next tokens that you can then spend to use telescope time. If you want to have a quick look through that, we have our website here, blah blah blah. You know how to read a website. The observatory owners bit here outlines the telescope stuff. What do you get if you put a telescope on and what's required? And if you want to be a member to use other people's telescopes and pay them, here's the membership stuff. So that's how you actually connect yourself to the NextAstro matrix to use these tools. You either have a telescope that's on there, know someone who has one on there, or you pay to be a member. But then you get access to this. This is a telescope somewhere in the world. It's in New Mexico. These are the last images that were on it. Weather's not good, so the roof's not open. But the last set of images was coincidentally a series of exoplanet transits images. And also Elon Musk transits. So there you go, satellite. But today we're looking at the exoplanet tool. How did that person get the telescope to take those images for them? Well, when you're looking at a single telescope, you look at the exoplanet tool. So the exoplanet tool allows you to skip to different nights and see what transits are happening on that telescope during that telescope's nighttime. So this is the night that's currently occurring, and up here it's 11:05 in the evening. And so here you see there's lots of conflicts because people have already scheduled stuff. And there's a couple of things we could schedule and transit that's already started. So let's skip forward to tomorrow night. Or maybe I'm going to get a good one. So here we go. Very good night. So the colors are to do with how visible the exoplanet transit is, like how observable. Basically, largely to do with its depth. The deeper the exoplanet transit, the more clearer it will be and the easier it will be to pick out of all of the little dots. So here we've got a Pandora target, which is cool because that supports a space satellite, and this is when an actual transit is happening at this telescope on that evening, which I think is a couple of days in the future. So here we can click and see where that Pandora target is, or where the exoplanet is in the sky over time. So it's altitude versus time. So it's in the second half of the evening. The transit kind of finishes sometime maybe about 4ish, and the observation needs to end about 5:35. You can click through and have a look at all the other visibility charts, and also estimates an exposure time for that particular star, depending on how bright it is. We record a couple of the project's priorities when they are available for that target, and how far the moon is away. This here is just a numerical version of the plot up the top. So you see the altitude down here is in the square brackets, and the time, local clock time for the observatory, is above it. And you have the RA and DEC. If you want to schedule the Pandora target, you just need to press schedule and it will do it for you. There's already an event scheduled during this time. Well, that's sad. Let's go to a different evening. WASP 92. Let's do that one. Schedule. Scheduled successfully. WASP 92B. Blah blah blah. You can stay on this page by pressing OK, or you can jump to the calendar, and there you can see there's the transit in the calendar, waiting till Sunday to be able to see it. So it's pretty much that simple to schedule an exoplanet on the telescope. So this is very telescope centric. It's not exoplanet centric, it's just the exoplanets of opportunity on that evening that you can see. Okay. So yes, if you have any questions, there's an email button up here which will take you to this user contact and support. So ping us an email. But the other way that we can use the tool is not from a telescope-centric perspective, but from across the network perspective. Because a telescope perspective, if you have a telescope on the ground, it can only see certain transits. It doesn't get to pick which exoplanets they are. It's just a coincidence of what exoplanets are going over the top and transiting at the time that it's nighttime. But if you want to go look across observatories, we have a thing called Exo Explorer. There's quite a few buttons and stuff, but I'll just give you a taster. So say you're a university student and you want to look over the course of 2 semesters or something, 2 months. I've made that. You can set how dim you want your exoplanet to be, how deep you would prefer it to be, and periods. So you probably don't want periods that are too long. 0 to 10 days. You can select specific observatories and include other telescope network sites, but here we have a list of the transits that are available during those 2 months. That transit. The number in the bracket is how many times it transits over available telescopes in the network. So if you add in more sites, you get more transits. And it's really to do with what sites you've selected, what sites you have access to, and what sites just coincidentally happen to be able to see the transit in the time period that you selected that are deep enough, bright enough, short enough. So this sort of sorts out the list of tens of thousands of possible exoplanets, because there's 6,000 known and then there's like another 10,000 of potential candidates, and gives them to you in this sort of prioritized list. So we put test targets in, get a whole bunch. One of my favorites is WASP 4843b. You get to see it a lot because its period is quite short. If we have a look here, its duration, the transit is 1.16 hours. The period is about 0.8 days. So here, if we scroll down, we have a little zoom in to the WASP site. We can see here is a bunch of observatories. Now you will see different observatories because I'm an admin person, so I can see a lot of different observatories. So you have what the site code is. So every observatory has its own site code. Whether you have to pay for it, if it's free. Some observatories are free. Some observatories are free to some people, not others. Some are paid, and some you won't even know about. In fact, I would say most of them you won't. But here we go. The first transit that happens can be seen by all of these telescopes. Not coincidentally, they're all Eastern Australia telescopes. So WASP 43b is not too far in the south, but it's in the south, -9. But the transit must be happening basically in the Eastern Australian time zone. Right? So this transit happens for all these telescopes. Then the third next transit, we've got one in Chile here. And then the 6th transit, we can see it in kind of California. And then Chile again, then back to Australia. And so you can see it's telling you which of its next transits you can see. So if we want to schedule a transit, maybe you've picked this object and you want to spend the next 2 months looking at all the different transits, then you probably go through and try and schedule each transit. So if we schedule this, it goes, yes, it'll cost that much, press OK. Now it's scheduled there. Okay, 3rd transit, okay, I'll try for this one, it's paid, it's in Chile, we'll press OK, and there we go, scheduled there. And then we go here, California, we'll schedule on this one, etc. So you can see, you can get your transits of your particular object from different places and different telescopes around the world by using this tool. So you can see we have 2 ways really that we can work with exoplanets, and there's lots of other tools and lots of other buttons. That's the 2 basic ways. You can use the exoplanner on an actual telescope that's physically located in one spot, and see all the exoplanets on it, or you can look at it from another direction and look at what transits does a particular exoplanet have on a bunch of different telescopes. You can also use this tool here that we're using across telescopes to just look at what's available on a single telescope. So if we go back over to where we were, we'll just start out again. He says, okay, refresh the screen. So if we do that again, he says, quickly retracing the steps, a couple of months. Now, if you set this, for instance, and you typed in Barren, which is a telescope in California, then you get a list of targets that are at that telescope in California, and that one only. But maybe you might want to chuck in your friend's telescope in Australia, but then you get ones that might be accessible at one time in California and one time in Australia. So you can see, if you can get a little group together of telescopes around the world, you can do cross-continental exoplanet things with your own scopes. But let's look at just this single telescope. So it's saying in the next 2 months, TRES 3b is the one that comes up at Barren the most. So there's 1, 2, 3, 4, 5, 6. I was sure it would be there as well, but there you go. So you can see, you can use this to plan what target you might want to look at on your own scope, or on a scope that you have access to, rather than across a whole entire network. So that's the brief overview of the 2 main exoplanet tools in NextAstro, but none of the actual details. There's lots more to find out. So, enjoy. Send us an email if you need to talk to us. I'll talk to you later.